Okay, in this example, if you remember how we solved in the previous example, then whenever they give us the relation between, so let me set this first, the heights in feet for time in seconds, then the typical heights function will be given by this way. And I already mentioned that negative 16 is just fixed, but everything else is depends on the initial velocity and initial height. So if they don't give us any information about it, we can guess that the initial height of the ball is 6 feet above the ground, and 40 means the initial velocity is 40 feet per second. Okay? But we don't need all the detailed information here, but roughly we can imagine our graph must look like starting from 6 feet above the ground, and it should looks like a parabola shape, and eventually it's going to hit the ground, right, at a certain time. So the question here is, how long is the ball in the air? Okay, so they are looking for the time being, right? Then we know the ball start going up in the air at t equals 0, right? No matter what. So all you need is just find out that time t, which is kind of at the intersection between this parabola and x-axis or t-axis in this case, right? So they just twist the question, but eventually asking same question, right? When the ball hit the ground, exactly same thing, right? So all we need is, once again, negative 16 t squared plus 40t plus 6 equals 0. So please remember where this equation comes from, right? I mean, you have to figure out the whole thing, right? So this function will be given to you, okay? Or you have to figure out that the initial velocity or something like that, but right, most likely it's going to be given. But what is the meaning of it, right? They try to twist the way of asking, but eventually, what is the highest, the heights, right, when the ball approach or something like that, right? So it's just typical in there. Okay? So anyway, so all you need is just try to solve this. We're expecting, because if you extend the graph like that, then one negative t-value and one positive t-value, right? So we are expecting that positive t-value, that should be the answer for this question. So after cleaning up all this mess, eventually we are looking for just solution for this equation. Right? Solve that equation or find t to satisfy the equation. That's all. So we already have enough practice for that. I believe you can solve this one.